Hello students, in this lecture I am going to start piezoelectric transducer. So we will discuss piezoelectric transducer. So what is piezoelectric transducer? Before going into the detail, let me tell you the word piezo means squeeze or press. Squeeze, piezo means press or squeeze. So what is piezoelectric? When you apply this pressure or when you apply this force or when you squeeze a material, because of that a charge gets generated on that material is called piezoelectric. So let's take an example. Suppose there is a quartz crystal. Quartz crystal is a piezoelectric material. So when you apply any pressure, or you can see when you apply force or when you squeeze this quartz crystal, what will happen? Charge will get generated on the surface of this quartz crystal. So this generation of charge on the surface of the crystal because of the application of force, pressure, etc. is known as piezoelectric property of crystals. So what is the basic concept? Why does the charge gets generated when such type of crystal are being pressed or when a force is being applied on such type of material? What happens? These materials, these piezoelectric materials, they have asymmetric charge distribution. So initially the center of gravity of positive charge and the center of gravity of negative charge, they collide with each other. They are exactly the same point. But due to the application of force on such type of crystal, or you can say when you squeeze such type of material, what happens? The center of gravity of positive charge is not equal to the center of gravity of negative charge. They get separated. As a result, charge gets accumulated on the surface of such crystal, and as a result electric potential appears across certain surfaces of the crystal. Now we have known this fact that when piezoelectric crystals or piezoelectric materials, when force is applied on such materials, charge will get generated. Means we are applying force as an input and we are getting charge as an output from the piezoelectric crystals. Now how this piezoelectric crystal is used for transducer? What will happen when you apply or when you place two metal electrodes on the sides of the piezoelectric crystal? So due to the application of force, the charge which gets generated on the surface of the crystal will be accumulated by this metal plates. And because of this property also, we can say the piezoelectric crystal works as a capacitor also. So what happens in a capacitor? We have this metal plates, there is a dielectric in between the metal plates, and the charge gets accumulated on the metal plates of the capacitor. Similarly, in piezoelectric crystals also, when you apply two metal electrodes on the two surfaces of the piezoelectric crystal, the charge will get accumulated on the metal plates. And why the charge get? Because the charge is generated because of application of force. When you're applying force to the piezoelectric crystal, charge will get generated on the surface of the piezoelectric crystal, and these metal electrodes will accumulate the charge, and therefore this piezoelectric crystal will work as a capacitor. And the charge so accumulated on the metal electrodes can be transferred to the other levels. This I will tell you in my later slides. Now let's discuss more about piezoelectric materials. As I have told you that quartz is a piezoelectric material. Basically piezoelectric material or piezoelectric crystals, they can be natural, means they are naturally available in the earth, or they are artificial or synthetic, that is man-made. And there are certain other crystals which are not piezoelectric, we make them piezoelectric. So the natural piezoelectric crystals are quartz and Rochelle salt. Artificial or synthetic or man-made crystals are lithium sulfate, ammonium dihydrogen phosphate, and then there are certain materials which are not piezoelectric in nature and we make them piezoelectric. So how we make them piezoelectric? Like barium titanate and lead zirconate, we actually rise the temperature of these materials above the Curie level, above their Curie level temperature in the presence of electric field, and then we allow them to cool down in the presence of electric field also, and because of that they retain polarization, and because of that they attain this piezoelectric property. So what is this Curie level? I told you that we heat or we rise the temperature of these materials above their Curie level. So basically Curie level is that temperature which is that level of temperature where this material loses its magnetic energy and lots of energy is released and a glow comes out. So that level of temperature where a material loses its magnetic energy is the Curie level temperature of that material. Now, next point about piezoelectric transducer, it is an active transducer. Piezoelectric transducer is an active transducer. So what is the active transducer? Active transducers are those transducers which do not require any external voltage or current supply for their operation. So in piezoelectric crystal, as I have told you, if you apply input force or pressure, you will get output charge. You are not applying any external voltage or current supply for this whole operation. We are not applying anything. So that's why piezoelectric crystal is known as active transducer, because it does not require any external voltage or current supply for this conversion. It is an inverse transducer also. How it is an inverse transducer? Now, as I have told you that piezoelectric crystal, the input is force or pressure, output is charge. Now, let me be more precise. We actually apply dynamic force or pressure. We do not apply static force or pressure. We apply dynamic force or pressure. Dynamic force or pressure means the force or pressure that is varying with time. The force that is varying with time is the dynamic force, and we apply such dynamic force to the piezoelectric crystal, and as a result we get charge from the piezoelectric crystal. Now, if the reverse, if we apply the input voltage to the piezoelectric crystal, what will happen? We will get output dynamic force, that is in the form of vibration. Vibration is what? Vibration is only dynamic force only. So what is happening here? We applied input dynamic force, we got output charge, and here again we are reversing it. We are applying input voltage to the piezoelectric crystal, and what will happen? We will get output dynamic force, or we can say when we apply voltage across the piezoelectric crystal, it will start vibrating. So piezoelectric crystal is an inverse transducer because input and output gets inversed. Now, as I have told you that piezoelectric crystal measures only dynamic input, that is dynamic pressure or force, that is vibration. It is not used for static input or constant input, means it is not used for static force or constant force. What will happen? Why we cannot use this static force? Suppose this is a piezoelectric crystal, and if we apply a static force, what will happen? We will get a charge across the piezoelectric crystal. This is the property. If we apply a static force, we will get a charge across the piezoelectric crystal. Now, as I have told you that piezoelectric crystal works as a capacitor because charge gets accumulated across the surface of the piezoelectric crystal. So we can say piezoelectric crystal works as capacitor. So again I am repeating, we are applying force to the piezoelectric crystal and we are getting a charge which gets accumulated on the surface of the piezoelectric crystal. Now piezoelectric crystal works as a capacitor. Now this capacitor will have some internal sensor resistance. It will have some internal resistance, and because of the imperfect insulation, what will happen? This charge will leak out, and as a result output voltage will get 0. So therefore for static charge the output voltage for a piezoelectric crystal gets 0, and because of this thing we apply dynamic, or we can say time varying force or you can say vibration to the piezoelectric crystal, so that we can get the charge. Now piezoelectric crystal, another property is piezoelectric crystal has directional sensitive property. Directional sensitive property means if you are applying tensile force to the piezoelectric crystal, what will happen? Charge will get generated. Obviously, you are applying force to the piezoelectric crystal, charge will get generated. But if you are applying tensile force, charge will get generated. Suppose in this charge is getting generated, suppose in this polarity, with this polarity. But if you are applying compressive force to the same piezoelectric crystal, charge will get generated with opposite polarities. So that's why we can say that piezoelectric crystal is directional sensitive. Or if you say, if you are applying force in this direction, the charge will get generated, the magnitude and the polarity of charge will get varied accordingly. So it has directional sensitive property. Depending upon the direction of the force, the polarity of charge will get affected. So the rest of the piezoelectric transducer I'll discuss in my next lecture. I'm ending this class here. Thank you.